2015. So, the advancement of big data happened in such a place. I mean, many of you guys are also, I'm guessing, familiar with the application of Spark, Apache Spark, and how it has transformed the way we manage, the way we compute data. So integrated cloud platforms, all the big players like the Amazons, the Googles, the Microsoft started investing in cloud platforms, and they realized that there is tremendous value in providing cloud platform service, which can do end-to-end data management, reporting, visualization, modeling, model implementation, everything. So that is when it started around 2015, 2014. The reports were, again, web-based, lot of web-based reports, automated reports, and deep learning AI became very common. I mean, the NLPs, the TensorFlows, simulation models, auto MLs became very common. And this is where everybody started thinking about productionalizing analytics. So earlier we were building models. We were not thinking about productionalizing these models. We were never thinking about building model pipelines. The ML ops word came into existence around about 2018. Okay, everybody started investing huge amount of money. The job market suddenly changed overnight from around 2015 onwards. There were plenty of jobs, and we will come to the specific roles later. Now, Analytics 5.0 is where we are heading. So 2025 is when we are, possibly going to reach a very different dimension of Analytics 5.0. So what will happen then? Quantum computing, big data on cloud, these will become normal for most of the organizations. The visualizations will mostly become AR, VR visualizations. I mean, the standard ones, Tableau, Power BI will also exist, but there will be a lot of these AR, VR visualizations. And then we will have some production-ready AI implementations. All your models, the models that we are investing a lot of time building, these models will become end-to-end industrialized, which means that you don't have to do anything with the models. You will invest enough energy and mind space to build the models, and they will become end-to-end automated. So this is a quick growth journey of analytics and where we are right now. So again, like I said, that wanted to give you a glimpse of this because this is important for the rest of the session. Now, this is how I define, based on my experience. I have led teams for the last 10 years, and I have been in the consulting space, like I said, for more than 10 years now. So this is how I see these are the major skills for tomorrow, and I call them the must-have skills, or must-have and good-to-have skills. The most important skill for you guys is your ability to problem solve, and that is what we are going to spend a good amount of time on this. If you guys do not know SQL and fundamentals of querying a data, I think you're lagging behind. I see a lot of profiles during my interviews, when I'm taking the final round of interviews. People say that, no, I'm good in AI, but I do not know SQL. I don't take that. You need to have knowledge of basic data processing. Then the fundamentals of mathematical and statistical deductions. How do you interpret, say, for example, something as simple as p-value? Those kind of concepts you guys need to have, right? And the basic principles of computational algorithms. What I mean by computational algorithms is every algorithm, the random forest, the XGBoost of the world, how do they really operate, right? Now, on top of that, these are, as I call them, the foundational skills. On top of that, for the next 5 years, the things are maybe the next 3. It's a very evolving industry. Things are changing. Big data engineering framework is going to be a critical skill that will probably play a big role. Plus the knowledge of cloud platform architecture. I mean, today with AWS and Google Cloud and Azure, almost the entire suite of analytics products are available on the cloud. So you guys need to understand the components, right? You need expertise in industry domain. A lot of you who are trying to sort of get deeper into analytics, build your capability in one domain. And one very important thing that is coming up is explainable AI and ML. For almost a decade now, we have just bypassed these questions from businesses saying that these are black box models. Okay. all the AI ML models are black box models. We cannot explain you the model. That is no longer going to stay put. So we need to come up with approaches by which the model methodologies can be explained, right? And finally, the implementation of analytics and MLOps principles. So again, very, very important topic. I normally take sessions on this topic, even in my organization, in my past organizations, and even outside. Very, very important topic for you guys. But yeah, that's what it is. The most important note that I would have for every one of you as we progress into the journey is, from your perspective, if you're not upskilling and evolving yourself on one or more of what you saw in the previous slide, you will not be able to sustain in this market. To stay relevant, you have to continuously upgrade yourself. So for me, like I said, I have spent 16 years, yet I have to learn almost every single day for the different business proposals, for the different delivery solutions that I have to build. Okay, we have come to the end of the first section. Good to take maybe one or two questions if anybody has.
Hi everyone, please paste your question in the Q&A section.
Gaurav has a question. I work in data testing team. My question is related to the use of automation for analytics. Is this the new future today? The answer, Gaurav, is a resounding yes, right? We are now trying to streamline and automate an entire journey of analytics. So, and as you will see throughout this entire session, that what we are trying to do today is, provide that entire view and go to organizations and say that, look, you don't have to do anything. You can just take the solution and you're done. Okay. Can you give me an example of an explainable AI? I'll come back to that, Anshuman. Do we need to know cloud platforms like AWS, Azure for becoming a data business analyst, data scientist? Do we need to know is, Krishnan, is a very high level statement. You need to know the architectures, right? Again, I don't know what kind of experience do you have, but yes, it would be good to get a basic foundational knowledge of that. Okay, Krishnan, I will take the last question now. Is Pandas an acceptable replacement for SQL? No, I would say, Mayur, because Pandas is a capability. SQL has many things that SQL has the ability to do, while Pandas can do in large part about 70% of that. SQL is a concept. You will need to, when you start dealing with data, SQL is a concept that you need to grab. Okay, I'm sorry, I will not be able to take more questions. I can see many, but I will come back to your questions in due course, right, guys? Okay, so we start with our analytics problem journey. Now, like we mentioned, that we are starting from the problem in its very raw form, right? What does a problem look like? A problem from an industry is extremely vague. So I go to many of these proposals, many of the business meetings with, let's say, the CTOs, the CIOs, the CMOs. They will give you a very, very high level problem statement, which absolutely makes no sense. And I have given 4 examples. They are vague. When you ask a question against that problem, you realize that there are too many unanswered questions and nobody is defining a clear outcome. So it is your job to define that outcome. And in many cases, businesses do not give you clarity around that issue. So we as analytics consultants, we as data scientists need to have that clarity in our mind to be able to answer and address those questions. So with that thought, let's go into typically for a business, there are 4 major strategic priorities. And when I say strategic priorities in layman's term, this is where they earn their bread from. This is how they generate money from the business. So what do? They either enable revenue growth. So let's say I am a business, I am a bank. I need to ensure that my revenue is growing. How do I do that? Through giving more loans, something like that. They need to reduce cost. So every business has a cost, operational and capital cost. How do I optimize that cost? How do I better make my processes? There are lots of inefficiencies in my process. How do I better make that? And how do I improve customer experience? So at a broad level, my dear fellow comrades, this is the landscape of problem that we are globally what we are trying to solve. Let's do a double click on this to understand this a little bit better. So this is called a typical customer journey. Imagine yourself as a customer, and let's say a telecom service provider or a bank or a retailer like an Amazon or a Flipkart, anybody who is providing you service to you as a customer. How do they view you, right? So what they do is, this is how the journey of a customer flows with time. So first they will do something called as a prospect assessment. Prospect assessment, what it means is they are trying to identify who is the right customer for me. A good example, Zomato. I mean, you are all aware of Zomato. Zomato has a very robust prospect assessment engine to identify whom should they onboard. I mean, if somebody is not a customer of Zomato, Zomato sends very, very specific niche kind of messages to people to get them on board. Okay. Just a second. Yeah. So once you have done the prospect assessment, you need to bring that customer into your data, into your books, as we call them. That is where you do an acquisition. Acquisition basically means how do you bring that customer on board? Once you've got them on board, we call the third phase is called the onboarding and engagement. So the customer is here. Now, how do I engage more with the customer? Again, let's take the example of Amazon. Amazon, you become you see a campaign, you see an offer on Amazon, you join Amazon. And then how does Amazon make sure that you are using their services more, right? They will send you very, very niche kind of messages saying that, okay, XYZ, I see that you like this product. Would you like to see this product? So that is where the engagement part comes into the picture. Now, once you are engaged, once you have become loyal to Amazon, these companies know that you will become loyal, you'll remain loyal to Amazon. So what they will do is they will do growth marketing. A growth marketing is typically when they engage with customers in a manner in which they are constantly asking you to try out something. They are telling you that, why don't you do this? Why don't you do that? They are trying to cross-sell something. They're trying to upsell something, etc. Then comes loyalty and operations. Loyalty is again very similar. If they figure out that you are also going to other let's say competitors like a Flipkart, I mean, they do get that data. They will try to create differentiated services. On the operation, they are ensuring that the customer service is on their toe. If you want to do a return, for example, you can do that return anytime. And churn and retention is when you are not engaging enough with Amazon. You have just stopped using Amazon at some point of time. That is when they get really worried, right? The last two, feedback and social listening, is what you are talking about, let's say on a chat, or if you're talking, if you're not happy with Amazon service, if you're going and writing in social media, those kind of information they are trying to gather. Finally, the end goal of every organization is to create personalization. A personalization effectively means that they want to give you niche personalized service. We'll come back to this at the end of our session today. Okay. All right. So now that we have defined this whole landscape, and as you can understand that there is analytics applicable everywhere, right from a prospect assessment to an acquisition to onboarding, growth, loyalty, etc. We are going to pick up one particular problem in the interest of our discussion, which is a very common problem of churn and retention. I'm guessing most of you are familiar with what a churn and retention problem is. Still, for those who are not, a churn or a retention means that a customer has stopped using a service. So think about it like a telecom. I'm a telecom and media expert, and most of my years I've spent in telecom and media and banking. So from a telecom and media perspective, let's say you are using a broadband service from, let's say, Airtel. One fine day you decide that no, my broadband service is not good, I'm going to switch to Jio. You call up the customer care, say that I'm done with Airtel, I'm switching to Jio. This is a churn, wherein you have decided to stop the service, right? Our definition of churn is industry agnostic. So we are saying that it could be for any service providing industry, for banking, for telecom, for retail, consumer goods, e-commerce, anybody who is providing you a service, a churn can happen there. What are the functions? Function typically means that from a business perspective, how do businesses tackle churn? So again, if you go back to the previous slide, loyalty management and churn and retention are two major functions which are associated with churns. Marketing, sales are also associated. We will come to that later. Again, I have given you a small description of what it is. I just explained that you do not want to continue with a service, or you do not want to renew. Say, for example, renewal is you're using a prepaid. You should have renewed at the end of the month, but you have not renewed. That's also considered a churn. Now, the reason outcome is highlighted because the outcome from a churn analysis or from a customer churn problem, that business problem, is where all the application of analytics lies. Okay, so there are 5 major questions for any churn problem anywhere in the world that we always try to address. This is exhaustive. Number 1, why are they leaving? Number 2, who are most likely to leave? Number 3, whom do I want to retain? Number 4, what kind of actions should I take to retain? Number 5, if I have taken an action, how should I target that? These are 5 major questions that we will address during our entire journey of going through the analytics problem. Okay. Question. Now, my question, again, this is an open question to you guys. So now that you have identified this, right, like these are the 5 major questions that I'm trying to address from a churn. What is the impact or the value that the business is trying to achieve by addressing this particular problem? Okay, so when the business is coming to you as a data science consultant or as a data scientist asking that help me solve my churn problem, what are they trying to achieve? Can I have a few answers, please, from anybody? You can post your answers on the chat if anybody wants to.
We have a few answers in the chat.
Okay. Yes, I can see a lot of answers. Ensure continuity and growth of your customer base. Yes, very good point. There are too many answers.
Yeah, right.
You have given a reason. Customer dissatisfaction is a reason. What I'm saying is, what is the impact? What is the value that the business is trying to get? We will come to the reasons later. What is the value that they are trying to get? Bring customer back, customer by renewing customers. Yes, I think Krishnan has a good answer. Krishnan says that by customer retention, as cost of acquisition is high, by renewing customer, they get better profitability margin. That's a very, very good answer, Krishnan. I mean, I'm not sure if everybody answers this, but this is the main thing why organizations typically do these kind of churn analysis, because cost of acquisition is very high. So they need to retain customers and ensure that we are able to sort of address that. What is the potential reason for churn and what could be done to increase profit, retain customers, ensure continuity, trying to increase revenue? Okay, I think let me actually give you an example. I think that would be better. So I think many of you have given this example, prevent revenue loss. I think I saw around 5-6 answers of prevent revenue loss. All of you are right. How do you do that? Or what is the step-by-step approach to prevent revenue loss? You first identify who are going to churn. You then identify what is the value of these customers, how much revenue they are generating. Are they generating a lot of revenue for me? Then I will retain them. That's as simple as it gets. But there is another angle also, which none of you have covered, or at least I missed that if it was covered. It is to optimize the campaign cost. Okay. What is meant by optimized campaign cost is that for any churn analysis, the churn is a big problem in the industry. So anytime you see a churn problem, you will see that people are spending millions of dollars in reaching out to people, and the people whom they are reaching out to, they are not actually going to churn. Whereas the people they have not reached out to with a certain offer, they have churned out. So this is a typical, for those of you who are familiar with what are true positive, false positive, true negative, false negative, this is a typical sensitivity, specificity, mismatch problem, right? So that is another issue that we will try to address using a churn. Okay. So now let us break down this problem further into an approach which is called a hypothesis-driven approach. A hypothesis-driven approach is a proven approach that the consulting firms, the analytics firms have sort of adopted for many, many years now. A hypothesis is nothing but giving you the answer why. Anything that gives you an answer why something has happened is a hypothesis, right? So any hypothesis-driven approach has 5 major, again, ways to solve that problem. What is my end goal? How do I reach there? What is the journey towards that end goal? What kind of input information would be required through the journey? What are the key milestones? I mean, if I have to reach there, what are the key milestones that I have to deliver? And finally, whatever I'm doing today, I'm building complex AI models, but is the business able to consume that? So these are the 5 major questions that I'm going to address through my journey, right? And this is what I'm showing you now is a step-by-step guide of how do we go there. So we have said that churn is a problem. We have said that there are 5 major questions that we are going to address in this churn problem. How do I reach to that end? I mean, if we go back to that particular set, how do I get an answer to all of these 5 questions, right? That is what we are traversing now. Okay. First, we do something called as a problem formulation, which is we build something called as an issue tree. Again, I would have loved to explain many of you how an issue tree works. Unfortunately, you can probably Google at the end of this session. An issue tree basically is when you're getting a problem, you're breaking down the problem into simpler blocks, which are easy to understand. I will give you a small example of an issue tree. From an issue tree, you build hypothesis. I will explain you how you build a hypothesis, and then you go to your data. So you break down the problem first into smaller blocks. For each of these blocks, you try to find a potential solution. For each of these solutions, you try to identify what are the data requirements, right? Once you've identified the data requirements, you go into your analytical approach, which is you do your hypothesis testing, you do your model building, you do your insights, you do your visualization, everything which comes under the analytical framework. And finally, you have to ensure that whatever you have built, again, I keep repeating this over and over again, guys, that has to be used by the business. So how do you ensure that whatever you are building is eventually getting used by the business? So that is what we are trying to address here. Okay. Okay. Like I said, like I promised, that a quick example of an issue tree. Let's go back to our customer churn problem. Why do people churn? Many of you have given all of these 4 answers. I've seen this: service quality, competition, other products and services, pricing. These are 4 major reasons why a customer would churn. Even if you break it down further, pricing, within pricing, you have market comparison, you have increase in prices, not usage-driven pricing. On services, you have misaligned preferences. Product holding is wrong. On competitions, others are giving you better offers. On service quality, you have too much downtime. Time to resolve that service is too low. All of these can apply to any industry. Okay. An issue tree does not end here. It just keeps on going till you have reached a stage where you cannot break down a problem further. Okay. I wanted to give you a glimpse of issue tree because otherwise it becomes very difficult for all of you guys to relate to what I'm talking about. The boxes underneath are called the hypothesis boxes or the hypothesis framework. So I've created one sample hypothesis box for each of the elements. So for custom pricing, what is my hypothesis? What I'm saying is, if your pricing is usage linked, it will reduce your churn significantly. Now you might argue that how am I saying this? Okay, am I just coming up with this from thin air? I mean, randomly? Not really. This is mostly industry business driven. So you need a lot of domain knowledge to come up with some base hypothesis. Okay, and obviously we are going to test this hypothesis from the data, which is what we are going to come to next. Similarly, on the engagement side, we see that if a customer is more engaged with all the other services, so we were talking about, say, a churn in broadband, they are not using Airtel broadband. Now, imagine if the customer has all other Airtel services. They have an Airtel TV, they have an Airtel mobile, they have other Airtel money and all the other products. What we often see is the people who have a full suite of other products and services, they are more engaged, therefore they do not churn from one of the products. Okay, competition. For many of my customers who are getting these very high value poaching offers from, let's say, differences from Jio, why not Airtel match that offer, right? So if I figure out that customer ABC is a good customer for me, I need to ensure that the customer is retained. I will match the offer that Jio is giving them. I will say that, okay, you need 200 GB more data per month, I'll give you that. Take it. Okay, you need unlimited voice calls, I'll give you that at no extra cost, but stay with us, don't go to Jio. That is called a matching offer. Low downtime. You are ensuring that, okay, many of my customers are leaving because the broadband is down, okay, in a particular area. I need to ensure that the broadband is up. And what we have seen is the moment you improve your quality of service, your churn always reduces. So the numbers that you see are again certain kind of industry benchmarks. So numbers indicate what is the percentage reduction in churn that happens when you start improving any of these. So this is how you build a hypothesis. So just to recap, you have a problem. From that problem, you build a problem tree or an issue tree. From each of these issue trees, you build your hypothesis. Now, once you have built your hypothesis, that is where we will go into the details of the problem in the next section. This is where I wanted to give you a glimpse of what kind of roles are involved across this journey. So we have talked about these buckets: the problem for formulation, solution framework, data engineering, analytics, and solution implementation. What kind of roles do you guys typically play? I have seen many questions around this in many of these forums that I take, and I've also seen many of you asking these kind of questions. So let us clarify this. And this is an important slide. We will take a pause after this just to take a few questions. So during the problem formulation stage, you will see it is mostly the business analysts, the domain experts, some very small representation of data analysts, a very small representation of data scientists. So all of them are sitting together brainstorming how to translate that business problem into an analytical problem. All the things that I did for the last 20 minutes, that's pretty much what we do. The size of the bubble here indicates the contribution. So you will see a business analyst or a typical consultant kind of a role doing a lot of playing a big role here, because they will look at the industry practices, they will look at the benchmarks, and accordingly they will try to come up with the hypothesis. Then comes the data engineering, which is as expected. The bulk of the work there is from a data engineer. Data scientist and data analyst also play a small role in that field of space. Okay. The analytical approach, which is where the model building, the insights, the visualization, everything happens there. Okay, so it obviously data scientist has a big role to play, a data analyst. And when I say data analyst, this includes visualization folks. So data analyst, data scientists have a big role to play. Data engineer also has a significant role to play because they are the ones who are building up the data. And we will come to the next section on data engineering right after this. And also the ML engineer. The ML engineer's role, for those of you who are not aware, is to implement these models. This is a new role that is coming up in the industry. People who implement models into an existing framework. So this kind of a role requires you to have understanding of models as well as understanding of a technical architecture, how a model can be sort of embedded into a framework, into a cloud, etc. And therefore, as you can see, that particular role plays a big part in the solution implementation, the ML engineer. The business analyst also plays a big part because they are the ones who are bringing all the entities together in making this solution a success. The ML architect is also a role that is coming up, guys. People who have an end-to-end knowledge. I mean, an ML engineer after 15 years will probably become an ML architect, or even a data scientist might become an ML architect. Somebody who knows the end-to-end architecture from data to value or data to implementation of a solution. Okay, quick recap of what we covered. We started with business objective. We talked about the data foundation. We will go into more depth of it. We talked about the third stage, which is building the model structures and what kind of roles are involved there. The rest of the things, model productionalization, deployment, whatever is in non-blue color, we are going to cover that in the subsequent sections. Okay, great. We have come to the end of this section. Again, we'll take maybe 5 or 6 questions. Okay, I have a question from Pratik. What we also need to understand is during a churn, the bad apples fall off too, and the loyal customers are what you should always, and we will come to this, Pratik, that this is a very, very important message that we will need to identify, and we have some very specific methodologies to do that. We will come to that, but you're making a extremely relevant point nevertheless. By data engineer, you mean data cleaning and feature engineering? No, Mayur. A data engineer, let's go through the data engineering slides. You will better understand what is being used, or what is the capacity of a data engineer's role right now. Ajit, your question is, what are the tools used in data engineering? I did not want to cover tools in this session, but I can give you a quick, sort of understanding of what you are asking. So, first of all, from a data engineering perspective, SQL is the most fundamental thing that you need to know. Without SQL, you cannot be anything, but definitely you cannot be a data engineer, because if you cannot write queries, you do not exist in the field of data engineering. Next, you move to a more complex form of query, which you can achieve using, say, for example, a Spark, a Hive, a Hadoop, all of these big data technologies which are enabling data extraction, etc. I don't know if you're familiar with a term called ETL, extraction, transformation, and load, but if you Google it, you will again get to know about it more. Then comes, okay, great. So whatever ETL tools exist in the market today, we have very, very sophisticated ETL tools, and in fact, Spark today exists as PySpark. I mean, it is so sophisticated the way PySpark is configurable. Again, I do not want to digress. We have limited time. Then the cloud architecture, again, from an integration perspective, we will come to that in the next few slides. Lot of configuration related knowledge is also essential from a data engineering perspective. Right? No, Anshuman, I've not gone into the slide as yet. I'm just answering the question from Ajit.
We have a few questions in the Q&A section, Amitayo.
Okay, I'm getting bombarded with many.
Right.
Business analyst versus business consultant difference. We'll take this question at the end, Aditi, if you can probably bring it back. What is the meaning of cross-sell and upsell? Krishnan. So Krishnan, cross-sell, if a customer is already, let's say, using an Airtel broadband and you are trying to sell them, let's say, an Airtel digital TV, that's a cross-sell. If you're using an Airtel broadband, speed 100 Mbps and Airtel is trying to sell you a speed of 1 Gbps, that's an upsell. That's a good simple example for you. Ashutosh, on a little bit of a tangent, where does ethics come into the picture? Whether the solution is used in the right manner, data privacy and legal knowledge requirements. Ashutosh, that's a very different topic on legalities, InfoSec. It's not in the purview of today's discussion. Again, it's a very, very elaborate topic that we can take some other day, maybe not today at least. I think that's it then. We will move on. What is the demand in the market for creating interactive web applications using Dash or Shiny? Extremely high demand. But again, not just on Dash or Shiny. Learn JavaScript-based technologies. If you know what a rapid prototyping is, developing applications in a very fast pace. Today, there is a big demand to build these rapid applications, dashboards, on top of JavaScript-based applications, Angular, Node, etc. Okay, so that is more beneficial as compared to a Dash or Shiny. Okay, Krishnan, my name is Amit Ayu. You can call me Amit. Unfortunately, I'm not Amitav. All righty. Let's move forward in the interest of time. We have still got a few more things to cover. Okay, so data engineering. Data engineering is something that we have sort of covered in tangents, beating around the bush. But what is data engineering, right? And as I call it, the reason for its existence. So data engineering today, like somebody said, that what is the scope of data engineering? First is it creates the foundation for all AIs. Okay, so bringing together the data from multiple different disparate sources, structured or unstructured, ensuring that that data is collated, ensuring that the data is ready for consumption, which is creating the foundation. Legacy modernization means that if you have an old platform, a lot of people, a lot of organizations are still have their data on old legacy platforms, like let's say DB2 or let's say certain dated versions of Oracle. Data engineer's job is also to ensure that this legacy platform is modernized into a modern data architecture. A modern data architecture is what I will show you guys over a slide in the next 5 minutes. Next is data lake mainstreaming. What is that? A data lake is where you store all your information. Okay, it's a consolidated view of all your data sources coming together into a unified platform. That is what a data lake is all about. Now, a design of a data lake, or a data lake followed by a data warehouse followed by a customer 360. I mean, I wanted to cover that again a little bit detail, but maybe not in today's session. All of that has to happen through a very sort of regimented process, right? There are lots of compliance related stuff, operations related stuff. I think Ajit or someone asked about data security and governance. That comes here in data lake mainstreaming. Next is cloud, something I covered on the very first slide. Now, in the future, in the next 10 years, all the data will come on cloud. There will be no on-premise systems at all existing in the next 10 years, hopefully. Even the smaller organizations are moving to cloud. So you need to have the foundational knowledge, know-how of the AWS, Azure, and GCP. And how does it sort of integrate with all other applications? A data engineer must also know that. Finally, a data engineer's role is evolving towards a stage where the consumption of data and consumption of analytics, dashboards, etc., are all getting enabled by a data engineer, right? So they are ensuring that your data is in such a state that you don't have to do anything. Automatically, data will be pulled from the source system. It will be fed into a data lake. From that data lake, somebody will pull the data, create a report. That report will be published. When the CEO wakes up in the morning, opens his phone, the report is right there at 7 a.m. in the morning. Okay, that is what a consumption means. And a data engineering team is end-to-end enabling these functionality. I call the data engineering as the powerhouse of, or the mitochondria of the today's data-driven world. We as data scientists, I am a data scientist for many years. So we as data scientists, we get all the credit. The data engineers are the ones data engineers are the atlases. So they are holding everything together and we are sitting on the top eating the cherry. So it's almost like that. Key responsibilities, like I mentioned, cloud deployments, a migration to a cloud platform, one. Governed data lakes, like I mentioned, moving data from your many different disparate sources lying everywhere in place into a common data lake platform is number two. Rapid insights discovery, the third point that I mentioned in the last slide, fourth point rather, that if you are to build an end-to-end solution, the data engineering team is ensuring that all the data flow, there is no gap in data flow in that solution, which is same as business self-service. So the business does not have to do anything. Everything will be enabled by the data engineers and data scientists. Modern hybrid architecture is a very interesting one. So you will see that in the next few years, while the companies are migrating to cloud, they're also maintaining their data on different other platforms because they cannot migrate it all of a sudden, right? But will the company wait for 5 more years till all the data is migrated to cloud and then work on the data science use cases? No. So how do they do it? So they create something called as a hybrid architecture. So wherein the data will also be used from that, on-premise platform plus the cloud platform to build your value. Smart data management is again related to sort of using various kinds of applications which are built by data engineers to ensure data quality, data flow, data streamlining, etc., etc. These are individually big topics. I'm trying to explain them in a very simple manner so that all of you try to understand. But again, I will try and answer questions at the end of this. This is like I mentioned, a typical enterprise data architecture. This is a big slide, folks. Now, there are lots of things. If I have to explain each of the components to you guys, it will easily consume our full time, right? So, what do you really want to take away? Let's look at the top headers, right? Raw sources. What are the raw sources? You have databases. You have files. You have third-party data, devices, sensors, etc. All of those, and also maybe cloud. In some cases, there are data in cloud. Now, our responsibility, our data engineers' responsibility is to, like I said, bring all the data together into some kind of a unified data model, which is right here at the center. But before you bring into the center, you need to ensure that the data is clean, the data is standardized, the data is integrated, etc. There are different types of data there. There are bulk data, there are streaming data, which are live data from applications. There are APIs, there are raw copies of files, etc. All of that streamlining is done by the data engineer into a unified model. On that unified model, they create certain kind of rules or certain kind of processes. Again, let's not go into the details of that, so that that data can be consumed for an information access. Okay, so if I have to write a query, or if I have to run a report, or if I have to run an API on top of that data, you need to enable certain functionalities and sort of components which will give me the information. And finally, the consumption is where the data is being used by the machine learning models, the applications, the BI reports, etc., etc. Okay. For now, you can ignore these two blocks, although these two are important blocks around something somebody was saying. Compliance is one of the very important issues. Master data reference or metadata management is an important issue. Data quality check is a very important issue. So all of these are a part of a typical enterprise data architecture. So you can imagine data engineering itself is a massive field. So many of you who are planning to build a career in data engineering, this kind of information becomes a good, helpful information for you. Okay, now let us get back to our problem. So our problem was that we were trying to address churn. Sorry, we were out of that problem for a while. Now we are coming back to the problem because we will, like I said, that we will pivot on this problem to ensure that you are able to connect all the dots. So how does it start with? We were trying to address a churn problem. First thing is assess the architecture of your business. Okay, end-to-end knowledge of how their data is there. We do a basic data discovery that for my hypothesis, what kind of data sources do I need? What kind of existing technology stack do they have? Is that data accessible? How do I access it? These are the initial steps of building doing an assessment of the enterprise data architecture. For all those of you who are a little advanced, you know what a sandbox is. So setting up a sandbox and setting up let's say a virtual workbench and connecting your data sources and your applications within the sandbox to your data warehouses and data lakes, that's also a part of the data engineer's role. This last statement is strictly for those who understand this architecture. For the rest, you can ignore. Okay. Then comes building up the data, which is what I'm calling as a development of an analytical data record. So for my problem, for churn problem, I need to build up an analytical data record, which is a customer level data set, which will help me build models or answer those 5 questions that I had highlighted. So I need to build up the data for that, right? This is what is going to happen. This is what the data engineer as well as the data scientists are going to do together. Remember that bubbles, the data engineer is the big bubble and the data scientist is the small bubble. This is that phase where the data scientist is getting involved, but the data engineer is again doing the heavy lifting. This tasks quickly, acquisition of the data, quality assessment, creation of the features, integration of the lakes, merge with the data warehouse, data dictionaries and metadata management. Okay, all of that comes under something that we call as a development of analytical record. Finally, for the implementation, again, the data engineer, again, if you recall that particular responsibilities, you will see data engineer has a role to play in the implementation also. What are those roles that they play? Many of you may not follow. For those of you who are following, what does a deployment mean? They create the data pipelines. So to end-to-end automate a solution, you need a data pipeline for your ML ops. That is what they are creating. They are creating the scaling and automations in the data to ensure that the codes are configurable, the codes are deployable. They are not just standalone pieces of code. They are parameterized, parameter-driven batch codes. They are doing feature engineering based on use cases for AutoMLs. AutoMLs are models that will learn automatically, and you need to have an automated feature engineering for that. They do that. And again, the metadata management also applies here. So this is what the role of a data engineer is. Now, before we move further into the analytics of things, I want to give you a glimpse of what is the output that a data engineer will produce. This is the output that the data engineer will produce for the purpose of our model, which is an analytical data record, which we also at times interchangeably call as a customer 360. A customer 360, folks, is a view of the customer by which all the possible attributes of a customer are brought together under one platform: financial, usage, service, products, channel. These are just some examples that I've given. Typically, when we build these exhaustive customer records, it has thousands and thousands of features that cater to many, many different kinds of use cases, not just churn. Churn is just one of those use cases. A typical 360 will cater to many, many different use cases. Okay, great. So we have come to the penultimate section, which is the inside data science. We have 25 minutes left. I think we'll take one more round of questions if somebody has any. Himanshi is saying, can you please explain ML ops? Okay. ML ops stands for ML operations, Himanshi. What that means is that the models that you are building today, how will that model be a part of a system that will continuously churn out results of, let's say, of a churn, and constantly provide those business leads and say that these are the customers who are going to churn every month, etc. But nobody needs to manually do anything, right? The data will automatically come, the features will get automatically created, the models will run automatically, the output will get generated automatically, the results will be sent out automatically. Okay. So that end-to-end process, end-to-end automation of of a machine learning journey is called MLOps. I have slides for MLOps at the end of this. You can probably I can probably show you that. Okay. There was another question. Are there no exception cases? What does that mean? I'm not able to follow that question, I'm afraid. Zinab has a question which says, difficult to separate data engineer from data analyst, data scientist, since exploring data with more patterns eventually correct the understanding. At the initial stage, Zinab, yes. I'm hoping that I'm pronouncing your name right. Initial stage, definitely yes. It's hard to sort of differentiate the roles, but as we go deeper into the solutioning, as we go deeper, the roles become more and more specialized. So initially, when we are doing an assessment of the problem, some basic analysis of the data, there is no difference. But then as you go deeper into the problem, the roles become very, very streamlined. What is the meaning of feature engineering and metadata? Krishnan, this is a very different topic, but feature engineering is essentially an approach by which you create certain kind of derived attributes from your raw variables. So let's say you have a variable called usage, your monthly usage of data. Again, let's take that same Airtel broadband example. Every month you are using, let's say 50 MB or 100 MB of data. Now, what is the average 6 months use of your data? So you look at the last 6 months of monthly usage, take an average, that becomes a feature. Okay. Metadata is like a data dictionary. Okay. A data dictionary essentially is an explanation of each of the fields and an explanation of how did that field come into existence. Because obviously you wouldn't know, you as a data analyst or a data scientist, you're not expected to know every business. So when you go and land up in a business, you need to understand what each of your fields mean. Okay. Last question I'll take. What is cognitive analytics and descriptive analytics, but seeing these new terms pop up? Cognitive analytics is primarily something which is driven by advanced AI, whoever was asking that question. So a self-driven car, for example, wherein the machine has to take a decision on its own, is a cognitive analytics. Prescriptive analytics is where we are trying to give a recommendation to someone. So all of you watch Netflix or Prime, the recommendations that come to you that, these are the movies or these are the TV shows that you should watch, is a prescriptive analytics. We have a component of prescriptive analytics in our solution also. Who is better, a data engineer or a data scientist? We are all good human beings, Himagiri. I mean, there is no good or better. Everything is important. Data engineer, okay. Cognitive analytics equal to AI. AI is the larger umbrella. Cognitive analytics, like I mentioned, anywhere where a machine has to take a decision is what a cognitive analytics is. All right. In the interest of time, we are moving forward. So now we have come back to those 5 questions, if you remember, right? These were the 5 questions that we originally had. Now we are trying to address each of these 5 questions with the help of analytics, with the help of data science. But before we do that, have we thought about something? How have we defined what is a churn? So generally, I have explained that if somebody stops their service, it's called a churn. But a churn could be a product churn or a relationship churn. Say you are, again, an Airtel customer. You have many different products. You have just decided to stop the services of your postpaid. That's a product churn. But you have stopped using service of all of the services, Airtel, TV, broadband, money. That's a relationship churn. How do you differentiate between churn versus an inactivity, or a hard churn versus a soft churn? Somebody who is inactive for a long time may often be confused as a churn because that person is not doing anything. We might often say that, okay, this person is not going to use my service any longer. but suddenly that person comes back. So how do you differentiate between that is something that you need to very clearly understand. Dealing with returning customers is the same point. If a customer has been inactive for a long time, suddenly comes back, do you want to call that customer as a churn? Voluntary versus involuntary. Somebody in your services whom you have decided to throw out yourself. Say you are a telecom service provider, somebody is being a very bad customer, not paying bills. You have decided to just let go of that customer. That's not a churn. You have thrown out that customer. So even though the customer has left, but he has left because you have asked him or her to leave. Okay. And then you have frauds. So frauds are doing certain fraudulent activities, leaving. Do you really want to call them a churn? So all of these questions need to be answered, and basis that we have three major aspects that we need to keep in mind. One is it has to be business aligned. It has to be clearly oriented with an outcome, and it has to be clearly quantified. So you need to mathematically express what is a churn. I'm not going to go into definition of the different churns because again, we don't have that much time left. We will assume that we have defined who is a churn in our data, and we are now trying to answer each of these questions. First question was the why question. Why are certain customers leaving? Okay, so I'll follow some 6 major steps. I will define a hypothesis that, okay, this was my hypothesis that I came up with from my issue tree, from my hypothesis tree, etc. I will go to the data. I will ask the data engineer that, look, this is my hypothesis. Can you tell me where do I get the data from? And they will tell me that this is where you will get the data from, which is called the attribute extraction. Then I may need to create a feature, as I was explaining to Krishnan, and I'm guessing most of you are aware of what a feature creation means. You create a certain variable or a derived variable according to your business problem to test your hypothesis. Then you do something called as a causal forensics, which is more around understanding the root cause behind a certain event. Then you do a statistical significance test. When you're doing a root cause, it has to be statistically true or mathematically true to say that, yes, this is genuinely a true hypothesis. And finally, you come to a verdict. Let's take an example. Customers who have less volume of incidents in your broadband, or customers who face less outages in the broadband are less likely to churn. That's a hypothesis. How do I test that? I will take all my customers. I will look at the churns. I will look at what volume of outages are happening there. If I see that churn is high within that group of population where the outage is high, I can certainly say that my hypothesis is true if it is statistically proven. Okay. Again, this is not a technical session, so I'm not going to cover what is a statistical testing or p-value. I'm assuming that many of you are already familiar with this. Now, this is Prateek's question. Okay, so I have answered the why question, which was at the first block. You may have noticed I have ignored the second question for a moment and have come to the third question. There's a reason. So Prateek was mentioning that every customer who is leaving may not be important to us. So whom do I want to retain and how do I determine that is typically done using an approach called as a value segmentation. So I categorize customers on the value that they are going to generate for me today, which is called the net present value, and future, which is called the lifetime value. Okay, so we build a different variety of models here. Could be some basic segmentation clustering models or some very advanced AI models to get to this outcome. But typically the result of that is something like this. We have very high value customers. So if you look at our data, we'll come to more details around the data. These guys are very high around the ARPU is the average revenue per user. So how much revenue they're generating for me? They're very high revenue. Their tenure is already more than 60 months. They hold a lot of products, right? Those are the very high value customers. So if I see that anybody is churning or anybody has an attrition likelihood from this group, I will definitely retain them. So must be retained with customized offers. I will need to retain them with special offers. I mean, I cannot just send them a random offer and say that I want you to stay back. Okay. Similarly, high value, mid value, and low value. One thing, I don't know if you have noticed this, the base size of these segments are typically, high values are very small, 5%, very high values. High values are about 10, mid values around 25, low values around 70. So the big chunk of customers in a typical customer base, regardless of what industry it is, do always come in the low value category. And whether or not you want to retain them is a decision that you need to take on an individual basis. Okay. But this is where your retention becomes very, very important. You definitely want to retain them. Okay. Now I have come back to the second and the fourth question together. Okay. So what I'm saying is, this is my AI-powered model engine. Right. What are the three major steps in my model engine? You first develop a model, you validate a model, and you ensure that your model is good enough to be deployed, to be taken forward. How do you do that? Whatever that model is. In development, you do your feature engineering, hypothesis testing that I've already spoken about. You do an algorithm selection. We do a lot of ensemble algorithm selections. We do a lot of specialized algorithms for specialized use cases, etc. And most importantly, we do an iteration. So we keep on iterating this process till the time we feel that, no, my model is looking good. How do you know your model is looking good? Through validation. So model accuracy, stability, and robustness. Again, you can read through them if you guys are not familiar. But again, the intent of this session is not to educate you on these parameters, but more around the performance of an overall, or a journey of an overall problem. Finally, value creation, model explainability, like I mentioned. This is an important value for businesses today. Automated ML frameworks is an important value for businesses today. And businesses today want an agile approach. What is an agile approach? Till the time you have not finished your entire, so for many of the analytics problems, till the time you have not reached the end of the model, which takes maybe 6 months, the business has got nothing to look at. They are just sitting idle, hoping that this model will give me some outcome, this model will give me some good value. That is not how Agile works. For those of you who are familiar with Agile, Agile works in sprints. So we have to create deliverables in sprints. And a typical AI/ML is a good example of how you can deliver different kinds of solutions to businesses and value to businesses in shorter sprints. So that is what we intend to do using our AI/ML framework in which we should build a model. Right. Now let us come back to the models that we are trying to build. So we are essentially saying that we are going to build 3 models for the purpose of this solution. One is a churn prediction model. So this is a propensity model wherein you will predict that which customers are likely to churn. Right. So on our data, you will tell the business that these are the customers who have a high likelihood of churn. The business will say, okay, what next? Now you will say, now I'll give you a value segmentation model, which you should overlay on top of your churn prediction model, which will tell you that these are the guys likely to churn, but this is the value on top of that. So if you see that a particular customer is high risk and high value, you would definitely want to retain them. The business is saying, okay, that's good for me. What next? But how do I retain them? So you say that, okay, for that, I have an offer recommendation model. So for every segment or even for every single customer, I will create an offer for you. And you can take that offer to that customer and you will be able to retain that customer. Okay. That is what an offer recommendation model is. Quickly, just spending a minute on the algorithm. So typically a churn prediction model will be a classification or a regression problem. Again, I mean, let's just keep it to that. It's typically going to be a classification, regression, or maybe a simulation problem. A segmentation typically is an unsupervised approach wherein you use clustering, hierarchical or non-hierarchical clustering, or you use the supervised segmentation also, something like a KNN or some of the advanced AI techniques for your segmentation. Offer recommendation model is typically a collaborative filtering or a rule engine. Collaborative filtering is the same algorithm that fundamentally lies in all recommendation systems around the world, be it Amazon, be it Netflix, be it YouTube, be it Google, whatever it is. And then in a recommendation model, what you need to have is something called as a test control mechanism, which means that every time you're sending out a recommendation to somebody, that effectiveness of that recommendation needs to be tested. So if you are sending out an offer to a customer, whether or not the customer accepts that offer tells you that how good your recommendation was, which is what gives rise to something called as a reinforcement learning. Many of you might be familiar with the term. So reinforcement learning reinforces the performance of a model with the help of this approach. Okay. Now imagine, so till this point, we were talking about 3 different models. Now imagine if we could build everything together in one model, wherein for every single customer, you could identify the right offer. When do I send that offer? Through which channel should I send the offer? Through what is the message that I should write in that offer? That is called a personalization. Okay. So a churn problem, the North Star or the end goal for many of the churn problems could be a personalization outcome, wherein for every customer who is likely to churn, you have a very specialized gift for every single customer, depending upon what is the customer value, what is the offer that you're planning to generate, through which channel will you target that customer, what message you will take to the customer. When I say message, I mean mail messages. Those are also very important. So have you seen that, again, good example of Zomato, they send you emails with your name on top. So the moment you see Dear Prateek, you feel, oh, okay, how they're sending me a pretty personalized email. These days, they are going even one level deeper. They are sending subject lines based on your other email topics. So Zomato has a subject line which says, you have been browsing, or you have been looking into you have been browsing Amazon a lot, and immediately you feel that, oh, okay, how do they know that? And you click on that email. This clicking is called a clickbait. Many of you, again, you guys are pretty young. All of you are probably familiar with a clickbait, but Zomato's objective is to ensure that you click on that email at least. And this is just a Zomato example that I'm giving. It applies to pretty much all the platforms. Okay. All right. I wanted to do this exercise with you guys, but I think we do not have a lot of time to do this exercise because we are short of time. So I wanted to show you how a value is getting generated from a business based on certain inputs, right? So if you have a 1 million base with the customer, for a customer whose ARPU annualized is about $60, monthly churn rate is 7%, and many other metrics are there. How do you get to a value? So we got to a value of 68% ROI, 3 million annualized saving. How do I reach that value is what I wanted to show you. But we just have 5 more minutes, so I'm going to skip this.
I think we can start, Amitayo. People are requesting to do that exercise.
People are requesting?
Yeah, asking.
Okay, just hold on for a second. Can you guys see my screen?
Yes, it's visible.
Can you see the Excel?
Yeah.
Great. Let's do that exercise quickly. So we are saying that the base is and again, let's take the same example, the churn example. Let's say this is a telecom. So the base is about 1 million is the base. And what did I tell you? That the ARPU is $60. $60 is an annualized ARPU. So when I convert it to monthly, it comes to $5. So again, to explain, ARPU means that customer is generating $5 for you. The churn rate, and I'm assuming that it's a standard churn rate monthly, it's about 7%. Okay. So with these 3 metrics, if I know that I have 1 million customers. I have an ARPU of 7%, ARPU of $5, and I have a churn rate of 7%. I can calculate how much is going to be the revenue loss if I allow the churn to happen. It will be simply a multiplication of these three, right? If you multiply these three, you will get to a figure of about 35K per month, right? So, sorry, 350K per month, I'm sorry. So, right. So, 350K per month is the, if you do not tackle your churn problem at all, this is the loss of revenue per month that is going to happen for you, considering this small base and considering a small ARPU, right? Now, what we're saying is we are introducing a few other things. We are saying the cost of a campaign, and when I'm saying campaign, I'm sending out a campaign to a customer for my retention. The cost of that campaign is $0.5 on an average, okay? And my total budget per month that has been allocated to me is 150K. That per month on retention campaigns, this is the amount that you can spend, and per campaign will cost you $0.5. Okay. So how many people I can target? I can target these many people, right? 3 lakh or 300K people I can target because I have been given a budget and I know what is my campaign cost. Now, this is what is the start of my modeling exercise. So my target is about 300,000 people in both the scenarios. In the pre-model scenario, you are just randomly targeting people. You do not have a model. So because the churn rate is 7%, you will be able to get about 21,000. If you target 3 lakh people, you will be able to get to about 21,000 of your churners. Okay. And when you look at the the actual churners that you are, okay, actually you need to know what is a response rate also. So a response rate is when you send out a campaign, the customer has to respond to you or not. I mean, not that when you're reaching out to a customer, the customer will immediately take up that offer. So typically in the market, the response rate is 5%. Okay. So if you're targeting 3 lakh people, that has only 21,000 churners, and out of that only 1,000 you will be able to retain. So you are spending a lot of money and you're able to only get these many churners per month, and therefore your savings is $5 multiplied by this number. Okay. And accordingly you calculate the ROI. ROI is how much money you have spent versus what is the savings. Now let us look at a model. When we go to a model gives you something called as a lift. For all of you who are familiar with a lift, we are saying that our model gives a lift of about 2.5, which is a 75% churn calculation in the top 3 deciles. Okay, so if I'm reaching out to about 300,000 customers, I'll be able to accurately get to about 52,000 of the churners, right? And again, out of that, I will be able to, based on the response rate, because I'm saying that my model will also be able to increase the response rate, I'll be able to capture around 4,000 of the total churners, and therefore this becomes my annualized savings. So this becomes my monthly saving, this becomes my annualized savings, and this is how I get the ROI. So that is, again, I mean, I know I rushed, but the idea was to ensure that you at least get an overall idea around what the approach is to give you, again, I can take some questions if there are any. Okay, cool. The last section on analytics value, we'll just need a few more minutes to finish this. Any few, oh, I see there are lots of questions. Can we get the Excel file? I can share the Excel file, not the presentation. I mean, a lot of people are asking me for the presentation. I cannot share the presentation as such. Okay. I will is the BAU approach? What is a BAU approach? Okay, Krishnan has a question on what is a BAU. BAU stands for business as usual, means that there is no model. Business is randomly targeting people. Okay, in that case, how do you deal with it? Right, that is what a BAU approach is. Do we have anything else? Nope. Okay, last 5 minutes, I will cover this section and move forward. The question is, why would you need to implement models? I think I've covered this in bits and pieces. This is an industry example, guys, from all the experience that we have. So typically, if you look at what kind of value AI generates, there are different levels of value that AI generates. What I have been talking about is an intelligent product, intelligent automation, enhanced interaction, but it also creates enhanced judgment, enhanced trust. So all of these are individual value levers which ensure that, you know, the outcome that you're trying to get out of an analytics use case, the outcome that you just now saw, is getting multiplied. So what the value that you saw just now is for an intelligent product, okay, and an intelligent automation in parts, but the remaining ones we haven't even covered. Okay, I mean, again, in the interest of time, I will not go into details of these, but the idea is, this is why you should implement your AI solutions, your analytics solutions. Okay, how do you do that? There are 5 steps. You have to understand the business processes. That's why I said that in the very first slide, if you remember, you should know your domain. Unless you walk into the shoes of the business, you will never be able to solve a problem, right? You have to start simple. You cannot solve everything on day one. Start simple, start delivering smaller values, and only then you can reach the goal that you saw on the previous slide. You need to have a digital mindset. You need to ensure that as much data I can get, I need to incorporate that data, and that will only transform businesses. The value framework that I just now showed you, this value framework is a must. When you're thinking about building these AI applications, this is a must. And this is something that I tell everybody. There are no silver bullets. There are no shortcuts. If we are to build something credible, right, you have to follow the steps. And that is what I tried covering today. It's not a one-day job. It takes months to build that credibility, but that is what you need to do. Somebody was asking, what is an MLOps? MLOps, like I explained, is a process to package, deploy, and move a whole solution into a production environment such that everything happens automatically. The entire journey of a machine learning lifecycle, from data identification to data extraction to data analysis to model development to model implementation, happens completely on its own in an iterative and experimental manner. So I'm not going to go into more details here in the interest of time. This is how we do it. Okay, so we have to do an MLOps framework. We need to have data, which is the basic data framework. We perform the feature engineering, we train test models, but at the core of it, right, we have to ensure that ML engineering, ML operations, the experiments, all the use cases, they all come together into a framework which the client can easily consume. And when I say consume, they can see that value that I was showing you. So imagine this is just one small use case of churn. And over there also, we are looking at one small value realization. There are hundreds of such use cases, each having many different dimensions of value. And that is how AI can generate value for you. Okay, right. Ignore the last slide. That was more technical slide for those of you who are interested. That brings me to the end of today's presentation, right? I always say knowledge is the only thing that is going to keep you alive in this industry. Read more, learn more. A lot of people say, I have spent 15 years. I do not need to learn, read more. I'm done enough. I just manage people. Do not stay with that false hope and expectation. That is not going to work, guys. You need to learn. Okay. For the Simpson fans, a small gift. Righto. Thank you very much, team. If there are any last few questions that you have, feel free to unmute yourself and ask. I would probably love to hear some of your voices if you're interested.
Okay, all right, guys. If you have questions, just raise your hands.
Dhanvantari is asking, tell me about the names of projects which I can learn data engineering. Tell me about the names of projects. I cannot give you a name of a project, Dhanvantari. What I can tell you is you can just go to YouTube and understand whatever I explained. You have understood a big part of it. But what you can also do is go to YouTube and learn about what are the building blocks of data engineering and data scientist. You will get a lot of information. Okay.
So Ayat Pasha has raised hand.
Yes, please go ahead.
Okay, so hi Ayat, you can ask your question.
I think Ayat is still on mute. I will meanwhile try to answer all the questions that are there on the chat. How to assume the hypothesis to solve problems, any techniques, who make them? The hypothesis is a combination. Hypotheses are made by domain experts. Again, if you refer to my slide, domain experts, data scientists, data analysts, everybody comes together to build the hypothesis. Somebody who understands the domain will contribute. A data scientist will obviously try to formulate it in the mathematical form. Then we have a question which says, as a statistician, which branch of data science would you advise me to concentrate on? Anything. Right now, data science is a budding field. It will probably continue to be so for the next 10 years, I hope. And, data engineering is coming up really big. Data science is coming up really big. ML engineering, ML architecture is coming up really big. So anyone would give you a great career ahead. Okay.
Hey, thanks, Amit, for the session. It was it was very educational. I had a quick question on that causal inference slide. Can you hear me?
Yes, go ahead.
Yeah. So I mean, is the industry, or like whatever the machine learning models today, is it like advanced enough to start figuring out the root cause, or is it usually, I mean, the correlation is not causation, is what they figure out, they usually say, right? So where is what is the state of art today, and how do you, what kind of, if you can give me some concrete examples, that'll be
I will
great.
give you a good example of that. First of all, you are right. The models themselves are not equipped to build an RCA, if that was your question, right? What happens today is it requires, and that's why the role of a data scientist or a data analyst still remains relevant, because the day the models start to do that, we will become irrelevant. Okay. So we bring our expertise, we look at correlations, we look at the data, we look at the business, and we talk to business and bring everything together to create that causation, right? So the causal forensics block that I had is not just one small block which is getting entirely done by a machine. It is a combination of, say, for example, 30% machine output and 70% discussions before we come down to a final root cause, if that answers your question.
Great. Okay, thanks. So just I mean, if you want to just throw names like 3 models that might get to that kind of conclusion in that causal block. I
So
mean,
there
do you
are
have any
some AI
references?
models which are causal AI models which are coming up now. I was recently reading about a certain set of causal AI models in telco, again in my domain, wherein you feed it in data, it automatically tries to identify certain causes. But again, that's just more of a scholarly article. I cannot give you a specific name, and that would be unfair also, because there is no, again, established process there.
Understood. Clear.
Sergi has
Thanks.
a question. Yeah. Sergi, go ahead, please.
Sir, please, I want to ask if machine learning or artificial intelligence can be applied in industrial chemistry, and specifically on perfumes or cosmetics, or this part.
The answer is yes. it gets heavily applied in industrial chemistry. It gets heavily applied in many of the industrial applications. What was the last thing that you said, Sajid? What did you say? Cosmetics?
Yes, on perfumes. Once I read it on LinkedIn. I saw it on LinkedIn that they are trying to apply artificial intelligence on perfumes so that they detect smells or etc.
Yeah, there's a very interesting story, Sergey. I mean, we can probably have a discussion later, maybe on LinkedIn or something. I can share a very interesting story that I came across some 5 years back. I was in South Africa, but maybe not today. On specifically on how can data science play a role in perfumes. But it's a very very interesting insight that somebody gave me who is from the perfume industry. Some other time, Sergey. Today we don't have a lot of time to cover that.
I think we can take just one more. Pranesh.
Hi, uh, I am with you. Thanks so much for the overwhelming presentation. I have a quick question. Like, we are bombarded with this big data, cloud technologies.
Mhm.
Will ever in the future data analytics be moved to edge?
It's already moving to edge. When you say edge, you mean edge computing, right?
Yes, edge computing.
Yeah, it is. It is already moving to edge in large parts. I mean, I'm currently working on a particular engagement where we are actually working on a system which is empowered, I would say, somewhat by edge computing. So it is already there. It's happening right now as we speak.
Okay, okay, understand. So I'm like looking at all the different articles up there. So just very curious
Yeah.
about.
So again, I mean, Pranesh, there are it's a very industry specific thing, to be very honest, because some matured industries who are matured with data have the capability to one invest that amount of money into that kind of a thing. It's a heavy investment, right? So
Yes, yes.
lot of organizations who have already realized value of AI through whatever you saw in my slides, they are now
Mhm.
going to that, taking that next step, moving to an edge or a quantum computing kind of a mechanism. But many of the other organizations, they are not yet there. So I don't know which industry do you belong to. So
I belong to a manufacturing industry, so I'm looking.
manufacturing industry, it is still maybe 10-15 years down the line.
Okay, okay,
Yeah.
okay. Got it.
Uh,
Thanks.
so I think, yeah, that's it. Thanks a lot, Amitayo. On behalf of Analytics Vidya, I would like to thank you for your time and for delivering such a wonderful session. And I'm sure our audience found it insightful, and hopefully, we can conduct more such sessions with you in the future as well.
Sure. Thanks, Manshi. Thanks for all the help and support in coordinating this. I hope this was useful to all of you, and hope to connect with you, in another Analytics Vidya session or somewhere else, maybe.
Yeah, yeah, sure, definitely.
Thank you very much.
Thanks, Amitayo.
Bye-bye.
And I would like to request the attendees to please fill in the feedback form. Let me just paste it once again in the chat. Hi guys, please do fill up the feedback form. And if you wish to conduct a webinar or facing difficulty in registering, connect us with the at editor@analyticsvidya.com. We'll be back with another session of data around 25th May and 31st May. The links I'm pasting in the chat section. Please do have a look at both of these sessions as well. Till then, bye-bye and keep learning.